this is something I've been working on recently, last year or so, which is a JavaScript interpreter for microcontrollers. So I guess, I really like microcontrollers. I guess a lot of you here use them quite often. But I found one of the real problems, especially on the ARM side, it's got a little bit better now, but with the tool chains. They were really originally designed for industry and maybe maintained by companies that have a sort of vested interest in keeping them non-free or crippleware. They're usually quite badly documented, bad multi-platform support, and usually you need an extra bit of hardware for debugging as well. And even when you've done that, you probably have silicon lattice and stuff if you're working at a low level that you have to work around. So Arduino makes it an awful lot better, but they solve the debugging problem by just not even trying. And I know a lot of you who've done it have probably used serial write and serial read, and it's not a great state of affairs really. The other thing is it really encourages a way of programming that's not very good for multitasking. You've got delay 500, delay 1000, whatever, and the blink example is a great one where that's the first thing you write with Arduino, and the first thing someone asks is, how do I blink two LEDs? And how do you blink two LEDs at different frequencies? Well, it's completely rewriting the whole thing, and it's quite difficult to kind of explain to someone. And the other thing is it's not really very low power. I mean, this board, some of the boards are different, but the Arduino, which is like one of the main ones, you can see it's got a little voltage regulator on there, but that draws 4 milliamps all on its own. So if you unplug the Atmel chip, it'll still run down the battery in a week. So why would you want to run a scripting language on your microcontroller? I mean, you can solve the toolchain problem. You just don't have a toolchain because it's all in the microcontroller. And it's obviously easy to inspect it and to change it, and that kind of does a lot of the debugging for you. Obviously that makes the development much, much quicker. And another really nice thing is if you've got the source code on the device itself, especially if you're probably not for production hardware, but more when you're doing stuff yourself. If you've done something and you come back to it in a year's time, it's a complete pain. I've got a few microcontroller projects around the house, and you come back to them in a pick, and you have to try and find out where you put that source code, which version of the code it was, which compiler you used. In fact, probably you've upgraded the compiler, and it may not even compile next time you go to use it. Again, it's really friendly, no seg faults, and it's just more fun having an instant result or something. And again, I mean, a lot of you probably grew up with these, and BBC Micro had an I/O port on it, and you could instantly turn things on and off. And it seems really weird that we've gone backwards. So why would you use JavaScript? And other people here prefer different languages. And really, when I was trying to find something, I wanted something a bit like C, with the same kind of syntax. I mean, the way it works with strings is completely different, but it's sort of like a very cut down C scripting language. A huge amount of people know it because of websites. There's an awful lot of learning material online. And it's quite nice that you can now have a system end-to-end. You can run Node.js on the server, you can run Espruino on the hardware, and you can, on the web browser, you're running JavaScript as well. So if you've got some code that you decide you don't want to run on the microcontroller, you can just cut it and then paste it onto the web browser, and it'll hopefully just work. The other thing is, I don't know how many people know JSON, but it's a very simple sort of data storage standard. It's kind of human readable, and it's basically a really cut down JavaScript that doesn't include any functions or anything, just writing the data. And it's kind of built in because it's part of JavaScript, so it's a nice way to store data and to send it between devices. And it's got JavaScript fits really well with the event-based model. Introduced a little bit with web browsers and then with Node to a huge extent. And events are really handy on hardware. I mean, I wasn't much of a convert when I started, but implementing it, you can see how it fits really nicely. So you can say, when you press a button, do this, a second later do this, and then a second after that do that. And each one can be a function that is called one after the other. So you get a lot of the good bits of interrupts without any of the pain of preemption or writing a 64-bit value in 2 sections and getting interrupted in the middle of it. The interpreter deals with all that for you. And the way Espruino is implemented, at least, you set a watch on a pin like a button or an input, an interrupt actually handles it and timestamps it to the nearest microsecond, and then it goes back and handles the JavaScript in the event loop. So even though it's not running it instantly, you can still do things quite accurately. Right, so because it forces you to write things in small functions executed one after the other, you effectively get cooperative multitasking, which is like a really nice side effect. I mean, it makes it easy to put loads of different stuff together. The blinking example of blinking an LED, you can just take that code for one LED and just paste the code for the other LED in, and they're completely different. You know, they don't interfere with each other at all. And because of this, you don't have this idea of write code, run it. You actually, the REPL, the command line interface, runs at the same time as, it runs at the same time as your code, you know, filling in the idle cycles basically. So you can change stuff while it's in the process of running. And this also means that it's great for power saving. The interpreter, it knows when it can go to sleep, for how long, you know, whether it has to wake up in interrupts or just the RTC or whatever. So that's great. And as I've said before, I think it's a bit underserved. Like if you're doing some kind of data logging in your house or you know, any like handheld device, you want battery life. And Arduino doesn't really do that very much. So if you look at a 700 milliamp hour lithium-ion battery, the kind of thing you'd get in a Nokia candy bar phone, you know, a Nokia phone lasts for 30 days on that. So it seems crazy that an Arduino that's just one chip will probably only run for 1 or 2 days. Like even the small ones are drawing about 20 milliamps, unless you put in like special sleep code. The same with Raspberry Pi and the Espruino, it'll manage to do it a lot better because it just knows it can sleep. So the power saving itself, it's not easy. You've got to do all this stuff, and usually that involves looking at the data sheet, the reference manual, which is probably like 1,000 pages, and then looking at the hardware abstraction layer and trying to figure out what the hardware abstraction layer is doing and what you have to call to make it happen. And that's, again, something that I've had to spend a lot of time doing. But the end result is that you just like one line and you've got something that will immediately put it into deep sleep and you don't have to care about it. And that will call the function every 60 seconds. So why wouldn't I just use a standard JavaScript desktop engine? Well, there's about 1 million times less RAM than on the PC. So like even the initial buffers are, you know, 20 times the size of the amount of flash you've got in total on the device. And you can add more RAM. A lot of people already do this. You know, most of these run Linux, but notably Tessel doesn't. They've got their own little thing that they've, their own JavaScript interpreter, I think based on Lua, isn't it?
Yes.
Yeah. So yeah, that would be interesting. But I kind of decided I didn't want to go that route. I wanted everything to run on one chip, so you could get the size down. So yeah, you've got this weird thing where on the PC, you know, this is very, very rough. You can read all your RAM in about a second, but on a microcontroller, you can read your RAM in a millisecond. So you've got to kind of think differently about how you use the memory and how you use the CPU. You know, maybe you don't care so much about speed and you care more about making the most of the memory you've got available. And just bring this home, this is the little favourite icon from, you know, the very top of the title bar of like the Espruino website. If you're running in 8K of RAM, this is in 32 bits per pixel what it will look like. In that, you've got to get your stack, you've got to get all the code you're executing and all the variables that it's using. So it's kind of a bit of a squeeze. So the software is purpose-built just to kind of take advantage of this. So it's not desperately fast, but it tries to cram as much into the memory as it can and to be a very usable system within that. You program it using just a terminal app, so either via serial port or it's a USB communications device. So you plug it in and it will appear as a serial port over USB. I say it's open source C on GitHub at the moment. And it's not just JavaScript either, it's got some built-in libraries, some of which are standard JavaScript ones. You know, the array, string, maths. But then there are a few extra ones like FFT to be able to read and write waveforms so you can do sound. There's HTTP client and server that's based on Node, so it's pretty much almost code compatible. And the graphics library, which with vector fonts, which is kind of a nice side thing, because often you have a display like this and you just want to be able to size the font to fill it. So if you don't have something, you can just type require, and the web IDE, which I'll show you in a bit, will automatically detect that. It'll load whatever you said off the internet and will load it into the device. The board itself is software pre-installed. It's a very mid-range ARM on it with 48k of RAM. So it's still way more than the minimum, but you can get an ARM with at least 96 on the same chip, and you can get like the F4s have significantly more than that. I wanted it to be a bit different. So it's got a little prototype area on the top, which is for SOIC chips, which are, they're just about as small as you can sensibly solder by hand without any special tools or like really nice soldering iron. So that was just like a nice thing to poke in the space. And on the bottom you can solder on a Bluetooth module, which is one of the totally standard HC05 ones. And if you solder on the Bluetooth, you can program it wirelessly because it's just a serial connection. And again, I've tried to think about the voltage regulator a bit. So in sleep, it'll draw about 110 microamps, and the new version will go down to about 50 microamps. I think I haven't tested that one yet. And so we're recently on Kickstarter, and we've got about 3,500 boards sent out in January or February. So I'll try and give a quick demo. So this is the web app. It's actually, this one's a slightly new design. Yeah, that's good. So it's got, on the right-hand side, you've got like a code window where, a little, what do you call it, hints that detect if something's wrong. So it'll give you some idea before you can send it to the device. But on the left-hand side, you've actually got a, if I had such a thing. Sorry?
Using like USB with native client? Or do you talk with server?
No, it's actually, so on the device itself, it's just an implementation of USB-C/DC, and on the computer, it's a Chrome web app, which actually has access to serial ports anyway. Okay. They've got their own API for it.
Oh. So you didn't have to bundle with USB or anything?
No, it's lucky, actually. So now there's a bit of garbage, for some reason got stuck in USB, and now you're talking to the board itself, so you can write a number directly. I'm just going to click this, which will send this really small bit of code over to the board. And hopefully I'll try and see if this works. Ooh, yes, that's better. Okay, so hopefully some of you can see that. So this weird-looking bit of stuff is a linear stepper motor out of the printer. I don't know if anyone knows a stepper motor, but it's like a brushless DC motor. You've got coils, and you energise one coil, and it pulls the motor round to face it. So if you energise all the coils in order, you'll be able to make it move. So on that array that I just sent over were the 4 pins that go to a motor driver, which is it's actually soldered on the, see my finger, onto that little surface mount prototype area. So hopefully, if I just do digital write to the pins, this is like I've tried to keep it a bit like Arduino so that it's, people are used to it. But in this particular case, if you give it an array rather than a single pin, it will not take a 0 or a 1, it'll take a whole binary number, and it will send one bit of that to each one of the pins that you specify. So if I put 1 in here, it should, I hope, see it move a little bit. And again, you can energize one of the other ones, and it'll move again. So you can define like a step order in here. Actually, I should say that that this is step order you need to make it move. There's the command history and everything. What you're seeing now is just the chip itself. So all the command history, everything is done on the chip. When you type a character on the computer, it's just going straight over and it's sending the bytes back. So there's nothing fancy going on in the web IDE. So if we step back and we change this to look up in the array, and we just do it by the length of the array so we can keep going. Hopefully. Right, so I go back, just define a function. So there's multi-line editor as well. And we define step initially. Oops, have I messed up? I think I have, haven't I? Yeah. I've still messed up. Okay, so now if I call doStep, we'd hope that it would move us a little bit. I don't know if you can see that. And obviously if I do set interval, then this will call doStep every so often. And hopefully we'll see it moving to the end. So yeah, we can type clear interval to remove that, and we can go back to as before. And you know, you can build up really quickly and really easily with this kind of thing. So for instance, I'm probably, how am I doing for time?
Got 3 minutes. But
3 minutes, okay. Well, in which case I'll cheat. Yeah.
We can get questions a little bit.
Yeah. Right, so this is my cheaty version of it. So if I just take this and then poke it back in here, just copy and paste it in, and I hope if I can say step 2, I can maybe give it a number and it will move. And the actual code for that, yeah, if I had a bit more time, we'd just kind of build it up. But you see it can actually change the interval as it goes. So you know, quite quickly you can make it speed up smoothly, slow down smoothly, and it's just like it's just a fun way of playing around with hardware, really. You know, it's a bit different to this idea of write it once, send it over. If it works, that's great. If it doesn't, try and debug it. This time you're kind of iteratively doing stuff and building up. So yeah, that's it.
Questions?
How do you do the number implementation?
Sorry, how do
you do the number implementation?
So it tries to be as near to JavaScript as possible, but it's actually got 8 bytes that it uses for each number. It actually tries to use a 64-bit int wherever possible, and then so if I type in, if I type in 5, that's fine. But if I type in 5 times 1.0, it will actually, whatever. If I type in 5 times 1.0, it will. You won't know that, but it's now turned it into a double, so that doubles do tend to propagate through your code, but actually it just saves a bit of execution time when it can.
Soft float.
Hmm?
It does soft float, does it always?
Yes, yeah. Unfortunately, on these there is no hard float, but even on the F4 where there is hard float, it's just float. It's not double, so we couldn't really use it anyway.
We've got more questions too. How, apart from numbers, how is CMA script compatible? Is it?
I'm trying to get it as good as it can be. So the main things that it doesn't have are regular expressions and exceptions. Otherwise, it's pretty good. There's one issue at the moment, which is being able to take a reference to a built-in function, but that's something that I'm working on and will hopefully be sorted quite soon.
Gary?
You showed an ARM example there. Do you have it running on small AVR chips as well?
No, I don't.
Is that feasible?
Yes, yeah, there's actually no ARM assembler in it at all. So it's quite easy to compile. It was originally meant to try and fit on a 4K RAM PIC part. So it's why things are done in a way that really crams the memory down. So it shouldn't really be a problem to port over. It's the hardware abstraction layer though, which does take an awful lot of time, as I'm sure Bogdan will know. So yeah, you can get it running, but if you want to have good SPI, I2C, timers, all the rest of it, it'll take a long time.
It's a great great project, and congratulations on your Kickstarter, which has done rather well.
Oh, thanks.
Look up while you mention it. Would it be a fair criticism to say that you could have achieved this if you really wanted to program in C rather than JavaScript by writing the C library that provided you with a time trigger timer, interval timer library? You could write set interval in C.
Yes, yeah, you could. And in fact, someone has done it for the Arduino, but you don't get this kind of instant terminal of being able to talk to it.
Deployability across shifting your code around between different platforms, fantastic. Ilya was next.
I was just wondering, because you actually showed the function that uses JavaScript timer. Do you actually attach that to a hardware timer or of any kind? Or?
So that's what it does is a bit weird in a way. So it's got the real-time clock, which is powered by the low-speed oscillator, but that's only 40 kilohertz. So it uses that and the system tick timer, which is always going, and keeps two in sync, so you can actually time anything down to a microsecond. So it's not using any hardware for that, but if you do something like analog write, it will automatically switch to using a timer to do the pulse width modulation.
Yeah.
How much user code can you get in a 48K part? I find when I'm programming on these things, I run out of space because I end up with too many strings, whereas you can store in all the code in the code.
So I mean, you're talking about what's the storage? Think about that. It's probably 36 kilobytes of code you could get in, but because it's storing it all in one area, you can kind of, if you write lots of code and don't want to use very much variable space, that's fine. It kind of shifts dynamically. The other thing is it's executing from source, so it doesn't need any space with bytecode, so it saves a bit of room there. And you can actually you can minify it because it's JavaScript. So the minified code actually does shrink down quite a lot, especially Google's closure compiler, which does some really good optimizations. So you can, that helps with it at least. And if you use a built-in module, sorry, not a built-in module, a module that someone's done on the internet, the module is downloaded and minified and then sent onto it. So yeah, I mean, if you're using little bits of other people's code, they don't take up as much space as you might think.
I think we're just about one more question and then we're moving on.
Unicode support? Do you do these strings Unicode strings or?
No, they're just 8-bit.
Okay. Great. Well, thanks very much. Hopefully.